Well, good morning, period 1 and 3. I am still on jury duty. And this week you are learning the last lesson of topic 2, which is called lesson 9, factoring special cases. It is in topic 2, section 7 of your textbook. The objective says we will be able to use shortcuts or formula to factor perfect square trinomial and difference of two square. Here I underline the two terms, which are perfect square trinomials and difference of two squares. So you first have to know what they are. Let's take you back to section 3 of this chapter. Recall that we have learned to square a binomial. So if you have a minus b squared, the shortcut was a squared minus 2ab plus b squared. Likewise, if the binomial has a positive sign in between, a plus b squared, then the shortcut is almost exactly the same, except that the middle term is positive. And back in 2-3, we have learned that if you have x plus 5 squared, you could do the box method, you could do the distributive property, or use the shortcut to get x squared plus 10x plus 25. Well, before you use the box method or distributive property, this thing right here is called the square of a binomial. And after you did the box method, the distributive property, or the shortcuts, then your answer becomes perfect square trinomial. And guess what? Today, we're going to work backwards. I'm going to give you perfect square trinomial, and then you're going to use the formula to give me back the factor form, which is the square of a binomial. Now, the standard form and factor form are still the same. So we call this the standard form because it's written from the highest degree to the lowest degree. And we call this the factor form because if you were to expand x plus 5, that's the same as x plus 5 in one parentheses multiplied by x plus 5 in another parentheses. Likewise, in 2-3, you also learn how to multiply the sum and difference of a binomial, where one parenthesis has a plus sign in the middle, and then the other parenthesis has a minus sign in the middle. And when that happens, the shortcut is to square the first term minus the square of the second term. Well, the factor form is called the sum and difference of a binomial, and the standard form is called the difference of two square. Why? Because difference means the minus sign. And then in between the minus sign, there is two squares. The a being squared and the b being squared. So those two are the two squares with a minus sign in between, and hence it's called difference of two square. So back in 2-3, we learned that if you were to multiply c plus 3 with c minus 3, you could do the box method, the distributive property, or the shortcuts to get c squared minus 9. So the c plus 3 times c minus 3 is called a sum and difference of a binomial, which aka the factored form. And the c squared minus 9 is the difference of two square, aka the standard form. Well, again, guess what today? You're going to, I'll give you the standard form, you give me back the factor form. We're going to work backwards from right to left. From right to left. Well, let's take a look at the first example. In example 1, there are two problems. So the part 1 is says factor x squared plus 14x plus 49. Well, here we're going to do it in two ways. And then later on, once we get to part 2, I'll show you why one of the ways will not be as convenient as the other method. So let's take a look at the first part. It says x squared plus 14x plus 49. First, I have to identify that the perfect square trinomial formula is that if you have a squared plus 2ab plus b squared, then it becomes a plus b multiplied by a plus b, which we'll later write it as a plus b to the second power. Now, let's take a look at the first term. Looks like if you have x squared, that means each parentheses, right, when you write your answer, must be x and x, isn't it? Because x times x is x squared. And then 49, well, you're going to find two numbers, which hopefully they're the same, multiply to get 49. Well, there's only one possibility, which is 7 and 7, okay? And you have to make sure that the middle term is the product of the a and b, and then you double that. So if you multiply x and 7, and then multiply by 2, x times 7 times 2, you do get 14x, which matches the middle term of this trinomial. So once you confirm that the middle term is pretty much twice as a and b, then that becomes x plus 7 multiplied by x plus 7, which becomes x plus 7 raised to the second power. And then you could box your answer. Okay? Now, alternatively, if you do not like the shortcuts, you could kind of cheat by using the x game. Now remember, this trinomial has a leading coefficient of 1. So either x game or x factor or star method will work. Okay? But for the most convenient method, we're going to use the x game. So on the top, you're going to put the c, which is 49. At the bottom, you're going to put the b, which is 14. And you're going to find two numbers that multiply to get 49 and add to get 14. Well, the two numbers are 7 and 7. Positive 7 and positive 7. So when you did the x game, you also get x plus 7 multiplied by x plus 7, which is x plus 7 raised to the second power. Now, x game might not work all the time as the most convenient method because sometimes when a number gets large, it's really difficult to guess and check these two numbers. And that leads to the next trinomial. Well, here we have 9a squared minus 30a plus 25. Well, let's recall the formula with a minus sign in the middle. So if you have a squared minus 2ab plus b squared, that's the same as a minus b multiplied the same thing, which is a minus b. And later on, we'll write it as a minus b raised to the second power. Well, let's check. I know that, well, if I were to see the number 9, to find the two numbers that multiply to get 9, and hopefully they're the same number, then it's going to be 3 times 3. And since there's two apples, you're going to split each apple into each parentheses. Okay? Likewise, for 25, you're going to find two numbers that multiply to get 25, which is going to be 5 and 5. Now you're going to check, is the middle term twice the product of a and b? In other words, is 2 times 3 times 5 going to get you 30? Well, in this case, it is. Actually, in all cases, it is. So therefore, the middle term matches the formula. So, and since the middle term is minus sign, both parentheses is going to be a minus sign. So it's going to be 3a minus 5 multiplied by itself, which is just same as 3a minus 5 raised to the second power. Okay? Now I'm going to explain to you why the star method might not work. Remember, in here, the leading coefficient is not 1, so you have to use the star method or the x factor instead of the x game. So in other words, you're going to draw a cross with an extra line in the middle. And on the top, you're going to put a times c. At the bottom, you're going to put b. Well, what was a times c? Well, a times c is 9 times 25. 9 times 25 is quite a large number if you were to do this mentally. So with a calculator, 9 times 25 is 225, and then the bottom is 30. And then remember, on both sides of the star method, we're going to put ax and ax, which in this case is 9a and 9a. If I were to ask you, hey, find two numbers that multiply to get 225 and add to get 30, that seems to be too large to guess and check. Really, it's too large to guess and check. But if you really actually did it, well, the two answers are 15 and 15. And then later on, you reduce these fractions. Well, look at these two fractions. They are the same fractions. So when you reduce it, it becomes 3a over negative 5, actually. Oh, I messed up because the 30 is a negative. So we're going to fix the star method by putting the negative sign in front of the 30. That means the two numbers are negative 15 and negative 15. Okay. Well, it still works, but it's not going to be as convenient if you were to use the shortcut, right? So the two fractions are 3a minus 5 and 3a minus 5, which is the same. But you do quite some math from the star method compared to the shortcut. Shortcut in this case is much faster and easier to calculate. Well, let's practice more on the perfect square trinomial. Here we're going to factor 4c cubed plus 24c squared plus 36c. Now, just like the previous lessons, every time you factor, always check to see if you could factor out any GCF. So we're going to put this in a hockey stick to see if there's any common factor. Okay, so we're going to find the GCF of 4, 24, and 36. And it turns out that there is a GCF, which is 4. Okay, so that means it's going to be 1, positive 6, and positive 9. And remember, we're going to take out some coconuts. Since all the terms have coconuts, we could take out one coconut from each of the terms. So we're going to put C here. That means the first term have 2 coconuts left. The second term has 1 coconut left. And then the last term has no coconut. Well, from here, you could either do the X game or use the shortcut. Well, I know that 1 times 1 is 1. So it's going to be 1 and 1. And then, 2 coconuts split in them into each parentheses. And then 9 is just 3 times 3. Okay. And then you're going to check, is the middle term twice the first term, which is C, and the second term, which is 3. In other words, if you do C times 3 times 2, do you get 6? And it turns out that yes, it does get 6. So therefore, the 2 parentheses are C plus 3 and C plus 3. And again, do not forget the GCF. So you could rewrite this as 4C multiplied by C plus 3 raised to the second power. Never forget GCF. A lot of students, including me sometimes, will forget to write the GCF as part of your final answer. Well, let's go to number 2. Here it says 25x squared minus 60xy plus 36y squared. So we're going to check GCF as well to see is there any common factor between 25, between negative 60, and 36. Okay, let's take a look. Well, it seems that there's nothing except 1 that goes into 25, 60, and 36. And what about the x's? Can I take out any x's from all 3 terms? Well, the first 2 terms have x's. The third term does not have x, so I cannot take out any x's. Likewise, what about the y's? The last 2 terms has y's. The first term does not have y, so I cannot take out any y's either. So, in other words, there's no GCF for this trinomial. If that's the case, we're going to go straight to the shortcuts. Now, recall that the shortcut was a squared minus 2ab plus b squared is just same as a minus b times a minus b. Well, let's take a look at 25. Well, 25 is just same as 5 times 5. And then split the x squared into x and x like this. Likewise, at the end of the trinomial, you have 36. So 6 times 6 is 36. And then you split the yogurt into each parenthesis. So each parenthesis has 1 yogurt. Now, since it's a minus sign, you're going to put a minus sign in both parentheses, but always check. Does twice, look at the middle term, is 60 twice 5 and 6? In other words, does 2 times 5 times 6 really equal 60? And not only that, does 2 times 5x times 6y equals to 60xy? If so, then you could use this formula. And from there, you box your final answer, which is 5x minus 6y raised to the second power. I would not, and I repeat, I would not try to do star method for this problem, because if you were to do star methods, look at what's going to happen. Your A is 25, your C is 36. What's 25 times 36? I don't even know. Unless you use a calculator. And if you use a calculator, 25 times 36, most likely you're going to get, I don't know, hundreds, thousands. And I don't think you really want to guess and check that. And at the bottom is negative 60. So at this point, we're not going to do this, right? It's going to be a big question mark here. So therefore, the shortcut is much better for this situation. Let's go to example 3. We're going to take a look at the difference of 2 squares formula. In example 3, it says factor x squared minus 25. Well, let's check. So remember the formula was if you have a squared minus b squared, that's the same as a plus b times a minus b. Well, let's check. Well, that means you're going to have 2 parentheses. First of all, I have to check that the binomial has a minus sign, which matches this formula. There's a minus sign. Well, if it's x squared, you're going to split the x squared into each parentheses, which is x and x. And 25, you're going to find two numbers that are the same that multiply to get 25, which is going to be 5 and 5. And all you have to do is to put 1 plus, 1 minus in each of the parentheses. And then that's your final answer. Very, very short compared to example 1 and 2. Let's take a look at part 2 of example 3. Here it says 4m squared minus 9. Again, we're going to match the formula. Well, we're going to have two parentheses. We're going to find two numbers. Hopefully they're the same that multiply to get 4, which is 2 and 2. Since we have two mangoes here, we're going to split the two mangoes into each parentheses. So one mango here and one mango here. The 9, we're going to find two numbers that multiply to get 9, and they have to be the same. So it's going to be 3 and 3. So 1 plus, 1 minus, and then boom, that's your final answer. Now, just like example 2, sometimes we do need to look into GCF first before you use these shortcuts. Well, here in part 1, we have 4m squared minus 36n squared. Now, I'm going to show you how to do it in two ways. First, I need to make sure that I could take out any GCF. So let's write it in a hockey sticks. So in other words, are there any common factors between 4 and 36? Definitely. So the common factor is 4. So 4 divided by 4 is 1. And then 36 divided by 4 is negative 9. Negative 36 divided by 4 is negative 9. Well, I cannot take out any mangoes, or I don't know what I could use for n. So I cannot take out any m or n's. So those stays. M squared and n squared, like this. Then from here, since it's a difference of 2 squared, remember the formula was if you have a squared minus b squared, that's just the same as a plus b times a minus b. Well, 1 is a perfect square, 9 is a perfect square, 2 mangoes is a perfect square, and n squared is a perfect square. So we're going to write them as two parentheses. So it's going to be 1 is just 1 times 1. 2 mangoes, we split 1 mango into each parentheses. 9 is just positive 3 and negative 3. So 3 times 3. And then split the n squared into each parentheses. So it's going to be m plus 3n and m minus 3n. And again, do not forget the GCF. So your final answer is 4 times m plus 3n with m minus 3n. Now let's say if you did not spot the GCF, you actually went to finding the two parentheses. Let's say, oh, I see 4 is a perfect square. 36 is a perfect square. Well, let's see what's going to happen. Well, here, 4 is just same as 2 times 2. So 2m and 2m. And then 36 is 6 times 6, right? So it's going to be 6n and 6n, 1 plus, 1 minus. Now, this is not your final answer yet, because remember, in each parentheses, you could undistribute the GCF or take out the GCF. Take a look at the first parentheses. Is there any common factor between 2 and 6? Well, the answer is yes, because they're both even numbers. So the greatest common factor here, it's going to be 2. So you're going to write 2, open parentheses, and then you divide all these by 2, which is m plus 3n. Likewise, the second parentheses, you could also take out 2. So you have 2, open parentheses, m minus 3n. And then at the end, multiply 2 times 2, you get 4, which is 4, open parentheses, m plus 3n, and then open parentheses, m minus 3n. Hey, you get the same answer, but using a different approach. Well, here we have a different exponents. Here we have x to the 4th power minus 16. Well, I see that there's no GCF between 1 and 16, and you cannot take out any x's from both terms. So since I know that 1 is a perfect square, the invisible 1 is a perfect square, and then the 16 is also perfect square, I could start using the shortcuts. Okay, that means we're going to have two parentheses. Well, 1 times 1 is 1, so we're going to put just invisible 1. And then x to the 4th, you're going to split into x squared and x squared. Now, 16 is just 4 times 4, so one of them is a plus, the other one is a minus. Now, you think you're done, but not yet. Now, the first parentheses, I cannot factor it anymore because it's a plus sign. Take a look at the second parentheses. Isn't that itself a difference of 2 squares again? That means I could split this into 2 more parentheses, right? Because x squared, I could split into x and x. And 4 is also a perfect square because 2 times 2 is 4. So we're going to put 2 and 2. 1 plus, 1 minus. So you always have to check whether once you factor, are the numbers still a perfect square? If so, you have to keep splitting it. Now, once you get to here, 2 is not a perfect square. There's no same number that multiplied by itself to get 2. So therefore, I could stop here. But again, do not forget, this is also a factor. So it's going to be x squared plus 4 multiplied by x plus 2 multiplied by x minus 2. Here, we're going to take a look at the last example. In example 5, it says factor m squared minus 26. Now, even though there is a minus sign, there's an m squared, right? So let's actually take a look. I could split the 2 mangoes into 1 mango in each parentheses, but then 26 is not a perfect square. There's no 2 numbers that multiplied by itself, you get 26. So therefore, I cannot really factor the 26. So therefore, when you get to this situation, we're just going to call it not factorable. Okay, because it's not factorable, right? You cannot make it into 2 parentheses. Sometimes we call this prime. When you have a number that's not factorable, right? Remember back in the days, we call those numbers prime number. So we also have prime for polynomials, same thing. In example 5 part 2, here it says x squared plus 25. Well, here x squared is a perfect square. 25 is also a perfect square. But however, there's a plus sign there. Well, let's revisit the formula. The formula was if you have a squared minus b squared, that just means a plus b times a minus b. The formula only works when you have a minus sign in between. It tells you nothing about what happened when the 2 perfect square has a plus sign in between. So that means we cannot use this formula, and you can't really factor anything as well. So when that happens, well, this is also not factorable. Okay, factorable. And it's also a prime. Okay, so not factorable or prime, however you want to write it. Now, some people are like, well, can I still use the x game? Because I see that, well, here the a is 1, the c is 25. Let's check. So c here is 25. And then b is, now since there's no middle term, it's going to be 0. Now, in other words, can you find me 2 numbers that multiply to get positive 25? I repeat, positive 25. And when you add, you get 0. Well, the only possibility is like 5 times 5. But then 5 times 5 is 25, but 5 plus 5 is not 0. Likewise, if you try negative 5 times negative 5, when you add them, you don't get a 0. So that means you cannot find 2 numbers to complete the x game. So therefore, it's not factorable or prime. Well, that's it for this lesson. I cover pretty much all cases that in regards to these 2 formulas. Your homework today is on Pearson, not Delta Math, on Pearson, which is 2-7, factoring special cases. And because you're using shortcuts, you do not need to show work. I repeat, you do not need to show work. Okay? Thank you.